Hello learners, I'm Professor Aman Rasul Faridi. In this session, we will be discussing an important concept of data representation and processing. So first we will start with data representation. Later on, we shall be discussing about data processing. In today's digital world, majority of us are making use of computers and many digital systems. So, in this kind of world, it is important for us to understand these important concepts and to understand the concept of representation of data or information. We will need to have knowledge of data types and binary representation of data, number system, conversion and representation concepts, data representation, textual, audio, video, image, the concept of data compression, data structure, data formats and standards. Then we'll discuss file systems, data storage, error detection and correction, data transmission and data encryption. Then later on, we will be discussing the recent development in data representation. So let us begin with the understanding of data representation. The data representation is the process of translating information into a format that can be stored and that can be processed by computers and other digital systems. It is important. Why? Because it is required for efficiency, it is required for interoperability, it is required for integrity. So let us discuss about what is efficiency. It is important to determine how efficiently the data is stored, how efficiently it is processed, and how efficiently it is transferred or transmitted. Next important thing is that it is important because we are using different types of system. So to have interoperability across the systems and platform, it is important that we ensure how data can be interpreted correctly. Next important thing is integrity of data, right? We are concerned about the data which has been stored or which has been transmitted. When it has been stored, it is retrieved, right? And it is exchanged or transmitted. So while storing and while retrieving and while translating, it is important that there should not be any change of data or information, right? Next, very important concept is understanding the various types of data. We all come across various types of data in our day-to-day life. Textual data, data in the form of letters, data in the form of symbols, data in the form of characters. Second type of data is numeric data, integers, floating point, numbers. They are all, numeric data. Audio, whatever I'm saying, right? The sound that is recorded, the music that is recorded. So that represents the audio data. In the same way, we all, create audio or we create a video and watch videos, video clips, which includes video plus audio together. So that is another form of data types. Images and pictures we come across, that is another way of representing data or information. Data is also available in a structured form, like which is available in our spreadsheet programs, that is available in databases in tabular form. So all these with different types of data are very important and we should know and understand about it. Whether it is textual or audio or video or numeric, any kind of data, how it is represented within the computer system or a digital system. Computer system or digital systems are basically electronic systems. So inherently they understand zeros and ones. So the system which is more closer to digital electronics is binary system, which is based on zeros and ones, like two digits. So only two digits are used. That's why it is called binary. Bi means two. So 0 and 1. So base 2 numerals, they are consisting or they are known as binary systems, right? So a 0 or a 1 represent a bit, right? Next important concept is the concept of number system. In computers, various number systems are used in order to represent, in order to manipulate data. These systems, they form the basis of how computer process information from very basic operation to complex operations, right? So broadly, there are 4 types of data that we come across. One is decimal system, which is the standard numbering system which is used in our day-to-day life, and it consists of, as we know, 10 digits starting from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So together 10 digits, 10 different symbols we use. Next important types of data, which is binary. As I said, binary means it used 2 types of symbols, zeros and ones, and this is the fundamental number system which is used for computing. Next is octal system of data, which uses 8 different types of symbols starting from 0 up to 7. And the fourth one is hexadecimal number system, which uses digits from 0 to 9, 10 letters, and the letters from A to F. So A representing A, 10, then B, 11, C, 12, D, 13, likewise. In number system, there are 2 important concepts which you should learn and we should understand. One is conversion and another one is representation. Very often, there is a need to convert the number system that we have just discussed. Say, for example, to convert the binary data into decimal, or decimal into binary, or binary into hexadecimal, and vice versa. So it is important to understand that how these numbers are converted, how it is done. So we'll discuss about that. Next important thing is data representation. Within the computer system, all the data, whether text, whether image, or whether instruction, or all, they are ultimately represented in binary form. As I said, that computer system or a digital system inherently use digital electronics, so that uses zeros and ones. So we'll focus first on conversion of data, which may be in, say, decimal form, or maybe in binary form, or which may be in octal form or hexadecimal form. So whether hexadecimal data or binary data or decimal data, they need conversion. So for you as a learner need to have understanding of how these conversions are done. We will mainly focus on conversion from decimal to binary system, binary to decimal system, decimal to octal, and vice versa, means octal to decimal, decimal to hexadecimal and vice versa, octal to binary and vice versa, hexadecimal to binary. So we'll mainly focus on this. Decimal system, as I said, uses 10 different symbols starting from 0 up to 9, and the base of decimal system is 10, and binary uses 2 digits, zeros and ones, and the base of binary number is 2. So let us start discussion on how number is to be converted from binary to decimal, and likewise decimal to binary, and likewise we'll take examples one by one and we'll discuss. Let us see the steps to convert decimal to binary. The first step to convert decimal system to binary system is divide the given number system by 2. Say for example, if we have some digit in decimal system which has base 10 and we want to convert it to binary system which has base 2, so what we'll do, the number which is in decimal system will become dividend, and the base of the system, number system which it is to be converted in, will become a divisor. So we'll divide the number by 2 if we want to convert the decimal into binary. Next, get the integer quotient for the next iteration. Divide it and record the quotient. Also record the remainder for the binary digit. Then this process is repeated from 1 to 4, and this is continued till the quotient is less than the divisor. Means if we are converting from decimal to binary, so we are dividing by 2. So if the quotient is less than 2, we'll stop there, and then we'll traverse from bottom to top, right, to record the digits, and that will give our binary digit. So let us start by taking an example. Say for example, we have a number 19 which is in a decimal number, and we have to convert it to, say, binary digit. So right, so what we will do, as I said, first write the number and divide it with the base of required. We have the base for binary is 2, so we'll divide it, right? 2 9s are 18. So what is the remainder? Remainder 1. Next, we'll divide it again. The quotient is being divided. 2 4s are 8. The remainder is 1. 2 2s are 4. The remainder is 0. Then 2 and quotient is 1. So we can still divide it. Why? Because we have to get it. 2 1s are 2. So now we have to read a traverse bottom to top, right? So it is 1 0 0 1 1. This is binary. So we have converted decimal 19 to binary, right? So from bottom to top, when we move, this is called, the first digit is 1. So this is most significant digit, and on the top it is the least significant digit. So starting from most significant digit to least significant digit. Now we move on. Next is, we'll try to learn to convert a number. We have seen the example of a number which is not having any fractional part. So it was a whole number. Suppose we have a decimal number which has both uh, real and fractional part. So say for example, we have this number and we want to convert this number into binary. So how we'll start? We will do it in 2 steps. Let us see what those steps are. First, we'll divide in 2 parts, fractional part as well as non-fractional part. For non-fractional part, we'll have the same procedure that we had earlier. But for fractional part, what we will do? We will multiply the given fraction by 2. There we were dividing, now we will multiply. Separately write the real part and the fraction part of this result. So suppose we have, this is the fractional part, so I'll do, we will multiply it with 2 and the result of real part plus the fractional part will be written like say this, and we'll continue, move on, right? So you have to repeat this procedure unless the resulting fractional part becomes 0. But this is not always possible. So in some case, if the fractional part does not terminate to 0, then find the result of the fraction up to as many places as required if it is given. Otherwise, you can go on and stop somewhere. Once it is through, a series of real part from top to bottom is read and it is traversed, as I said, from top to bottom, and that will give you the required number in base 2. After this, first we calculated real part and second we calculated the fractional part. So we will combine real and fractional part. So that will give you the required binary number. So let us do it by example. For real, we have a number, decimal number with real and fractional part. So first we will convert the real part and then we'll convert the fractional part into binary. So we'll begin with real. This is 19. And as we discussed, we'll start dividing 19, the number, real part, into the binary. So for that, we'll record the quotient and we'll record remainder here. We'll record quotient and remainder here. We'll record quotient and remainder here. This is 1, 0, 0, 1, 1. So we have converted the real part of it. Now, next important part is we have to convert this real part. And for this, we discussed that we will multiply it with 2. So what we will do? We will multiply it with 2, right? And we'll record real and fractional part. Then right, so it has become 0. So now we'll take the real part and traverse from top to bottom. So it is 0 and 1. And we have to now, this was step B. So we have now to combine A and B. So it is 1, 0, 0, 1, 1, 0.01. So this is how a number decimal number having both real as well as fractional part, how it is converted into decimal to binary. Next, we will focus on how to convert a given binary number into a decimal number. So for that, we have to follow few steps, and you can see what are those steps. First, we will multiply each digit in binary number starting from the rightmost digit with the exponent of the base. So what we will do? We will multiply it with, say, 2 and its exponent. And exponent we shall start from 0, then we'll move right to left, then 2 to the power 0, then next digit into 2 to the power 1 plus next digit, then 2 to the power 2, 3 and so on. After that, you simplify each of these and add them like it is mentioned here. Let us take an example. Say for example, we have a number 1, 1, 1, 0, 0, 1, 2. Okay, and this is decimal number and we have to convert it into, binary number, and we have to convert into decimal number. So what we will do, we'll start from the rightmost digit, which is the least significant digit. So this, then 1 into base exponent 0, then this one 0 into 2 to the power 1, then this 0 into 2 to the power 2, then 1 into 2 to the power 3, then 1 into 2 to the power 3, then 1 into 2 to the power 4 into 2 to the power 5, right? What now we have to do? We have to simplify it. 2 to the power 0, 1, so the result is 1. 2 to the power 1 into 0, result is 0. 2 to the power 2, but into 0 is 0. 8, 16, then 32. Now we have to sum up all these. So what will be the result of adding these? The result will be, so a binary 1, 1, 1, 0, 0, 1. When it is converted, it is equivalent to 57 decimal. I hope you are understanding it well. Next, we'll discuss how to convert. This was the whole number. How to convert a binary fraction into the decimal number. For that, we'll see the steps to be followed. The first step, when we have to convert a binary fraction into a decimal, we'll do it in 2 steps. In first step, in part A, we'll convert the integral part of the binary. Then in part B, we'll convert the fractional part to binary. So after doing these 2 conversion, the next would be, we will add what we did in part A and what we did in part B, we'll combine, add them. So let us see. To convert the integral part of binary, we'll multiply each digit of the given number from left side of the radix point. Say radix point is this. So if we have a number this is your radix. So this is left side and this is right side. So what we will do, all the digits, binary digits from radix to the left side, we will multiply each digit, right? And we'll always begin with 2 to the power 0, then next digit 2 to the power 1 plus next digit into 2 to the power 3. Likewise, we'll move on. And after that, we'll simplify it like we did in the last example. Then next part is to the right of the radix point, we have to divide it. Each digit on the right hand of the radix point will be divided with, starting with 2 to the power 1, then plus digit 2 divided by 2 to the power 2, 2 to the power 3, right? And then we will simplify it. And after that, we will add both integral and fractional part. So let us take an example and do it. Suppose we have a number 101.101 and we have to convert it into a decimal number. So what we discussed, first we will do it for integral part, then we will do it for non-fractional part, right? So let us start. What we discussed, will start with this, right? We will start from here, from left side of the radix point, and this is 1, right, into 2 to the power 0, then 0, 2 to the power 1, then 1, 2 to the power 2. We will simplify it. So this is 2 to the power 0, 1, this is 1, this is 0 into 2 to the power 1, this is 0, this is 2 to the power 2 into 1, 4, right? So we will simplify it, and this is 5. Now from the right side of the radix, again we have number 101. So what we have to do, we will start from this digit, from the right part of this radix. We will start with 1 into, we'll divide it by 2 to the power 1, then 0 into 2 to the power 2, then 1 into 2 to the power 3. So 1 into this plus this is equal to 0 plus 1 upon 8, right? Now 1 upon 2 is 0.5 plus 0 plus 1 upon 8 is 0.125. Now we have to simplify it. So adding this will give you 0.625, right? So this is decimal. This is decimal. So in the third step, we have to add A and B. So what is our result? Our result, we have to add this. So 5 plus 0.625. So it is 5.625. This is the answer. I hope it is simple and easier for you to understand. So dear learners, today we have seen how numbers are converted from decimal to binary and binary to decimal. We discussed the example of the whole number decimal conversion to binary. Then we discussed binary number to decimal number conversion. Next, we discussed how to convert a decimal number which has both real and fractional part into binary. In the same way, we discussed how to convert a binary number which has real and fractional part into the decimal number. So here we stop, and in the next lecture we will discuss decimal to octal, decimal to hexadecimal, and likewise vice versa. We will discuss those concepts. Thank you.